Hello everyone, welcome back to lesson number 17 for Calc BC. We are in our fifth and final video for integration techniques. This entire lesson has been integration technique after integration technique, and it's just crazy how many we are doing in this particular lesson. So I've got two more things I want to show you guys, two more examples to show you here in this lesson, and the first one is number 6, where we have the integration of x squared plus 6x plus 1 over x plus 4 dx. Again, ladies and gentlemen, you always want to try that. That's usually the best thing, but in this case, U-sub does not work. So what we must do here is long division. So this is our next strategy, is long division. Some students can use synthetic division. You absolutely can use synthetic division if you want to. Either one is fine, as long as you know if you're using synthetic division. Just make sure you know what the numbers mean, and I'll show you that as well. Once I solve this using long division, we'll do it with synthetic as well, and just make sure you guys understand the numbers at the bottom, what they represent. All right, so you're going to take your denominator and you're going to divide it by your numerator. And again, this polynomial that we're going to get up here is going to be equal to what you see right here. So x times what is going to give you x squared. That's going to be x, right? So x times x is x squared. We're going to multiply 4 times x, and then we're going to draw our line, and we're going to change our signs. All right, draw lines and change our signs. So these are going to be 0, and then we're going to get 6x minus 4x, which is going to be 2x. I'm going to draw the 1, plop it down, and then I go back and say, okay, well, x times what gives you 2x? Well, that's going to be a positive 2. So 2 times x, again, is 2x. 2 times 4 is going to be 8. We draw our line, and we change our signs, and we're left with negative 7. This is the remainder of our problem. So we're going to then put minus 7, and then remember what we did when you guys learned long division, hopefully you did, you're going to have, it's the remainder over the divider. So negative 7 over x to the fourth. So I can now say that this is equal to the integration of x plus 2 minus 7 over x plus 4 dx. By using long division. Now before I erase this, let me really quickly show you guys synthetic division. So again, choose whatever you like for it. So you want to set your denominator equal to 0 and solve for x. So x minus 4 equals 0. X is going to be equal to negative 4. So in the box for synthetic division, you're going to put a negative 4. And then you're going to put your numbers up here, 1, 6, 1. And I should have said earlier, actually, if this had been an x cubed, then remember that you would have to put a 0 for the placeholder for x squared, and you would have done the same thing here. So if this had been an x cubed, you would have had 1x cubed plus 0x squared plus 6x plus 1. So just remember that. So drop the 1 down. You're going to multiply the negative 4 times this number, which is 1, and you're going to get negative 4. You're going to go ahead and subtract these. Well, you're really adding these numbers together, but in this case it's subtraction. So 6 minus 4 is going to be 2. You're going to multiply the negative 4 and the 2 to get negative 8. You're going to add these again, which again, you're subtracting negative 7. And so these are the coefficients that you see. So 1x, because remember this was an x squared, so this becomes an x. This is an x, so this is going to become the number, and this is going to end up being the remainder. So if you do synthetic division, which students like probably a little bit easier, then remember that this is now, it's 1x plus 2 minus 7 over the remainder of x plus 4. All right. If for some reason you do this and you get 0, your remainder is 0. Another strategy that I should have said earlier is you could have factored. Maybe try factoring this. If this factors and an x plus 4 is one of your factors, then take it out. And then it becomes a really, really easy problem. So maybe U-sub is the first thing you want to do, and then maybe after that you want to do some factoring. Okay, so I went ahead and got rid of the policy, or how we get from here using the long division or synthetic division, and now all we have to do is integrate this, right? And this part becomes actually pretty easy. So I'm going to go ahead again and just split everything up. And you don't have to do this. It's just that I want to show you guys every single thing for these problems. And my main focus is really just this right here. Like this, we know how to integrate these two things. So I mean, I'm not going to even waste too much energy. The integration of x is just x squared over 2. The integration of 2 is just going to be 2x. But then we get over here. We get over here and we get some number over some function, x plus 4. So what we can do here, and remember this is not squared, this x is not squared, so it's not an arctangent. So this is where we're going to actually use our good old friend u substitution. So we're going to actually apply u substitution for this. So we're going to get u is equal to x plus 4, and our derivative is going to be equal to 1 dx. So this would end up being, ladies and gentlemen, minus the integration of 7 over u du, which I could also pull out the 7, and I'm left with 1 over u du. And we talked about this in one of the previous videos, is that 1 over u is the same thing as a natural log. So when we're integrating this, it's going to be minus 7, and it's going to be the natural log of u plus c. And it's actually the absolute value of u plus c. So this answer is going to be 1/2 x squared plus 2x minus 7 natural log of the absolute value of x plus 4 plus c. Okay? So the reason this question is given to you, other than the fact to refresh your memory on long division and or synthetic division, is when you have a number over a function and the derivative of that function is 1. Okay, if the derivative of that function is 1, then natural log is what you're going to do. The natural log is what you're going to do for that problem. Because you will use the u sub, and you'll realize, again, if the derivative is 1, then you're just going to have 1 over u. And again, remember, the integration of 1 over u, 1 over x is just going to be the natural log. Remember, you only apply this, though, you only apply this when this is a singleton of 1. The power is 1. Not 2, not 3, 1. 1, 1, 1, 1. Okay, I got one more example to show you guys, and it's over here in example number 3. In example number 3, it says the tangent squared of 3x dx. Now, we talked about this before, that if we integrate tangent, we would do sine over cosine. Well, if we rewrote this in terms of sine and cosine, we'd have sine squared over cosine squared, and we can't do anything with that. We can't integrate those. Just because, again, and I'm going to show you this, and this is absolutely wrong, so I'll put it over here. So if you do this, right, so let me just actually show you guys why this doesn't work. So we do this, and let's make u equal to cosine squared x, or cosine squared 3x. Your derivative, remember, this is the same thing as this. And so your derivative is actually going to be 2 cosine 3x times negative sine of 3x times 3, right? So there's a lot of stuff going on that's wrong here. We can't do that because we don't have another sine. We don't have a cosine of 3x. So this is a big old bad. The reason I showed it to you guys again is just maybe just a quick refresher on how to take the derivative of a trig function to a power, right? Remember, you have to put it outside and then you do it this way with using the chain rule. So what is another strategy that we can have? Well, we actually know that 1 plus tangent squared of x is actually equal to secant squared x. And this x is just theta, so just theta. So I can say that tangent squared x is equal to secant squared x minus 1. So let's rewrite this in those terms. So I'm going to go ahead and say the integration of secant squared of 3x minus 1 dx. Now, why is this actually helpful? Well, this is helpful because we actually know how to integrate secant squared. We do have to use u substitution, right? So we can't forget that. So u is going to be equal to 3x. Du is going to be equal to 3 dx. And so I'm going to go ahead and pull out the 1/3 du dx. And so I'm left with the integration of 1/3 the integration of secant squared of u du. And I'm just looking at this because you guys know that this part here is just going to be minus x, right? So this we know how to do. We know that this is going to be tangent of u. And again, I'm going to go ahead and do the minus 1. So this is going to be minus, well, we'll get to that in a second because I don't want to confuse the x in there. So this is going to be tangent of u, which means this is going to end up being 1/3 tangent of whatever u was. Well, our tangent was going to be 3x. So that's this first part right here. And now I still got my negative 1 that I need to integrate. So we could, if I wanted to, be consistent with this, right? Consistent with this. So plus the integration of negative 1. Well, that's just going to be negative x plus c. So this is going to be your answer to your function right here. So when you have a trig function squared, most likely it may help to remember your Pythagorean triple. of your trig functions, and we write them like that. So now you know how to integrate tangent of x by writing it sine over cosine, and now you know how to integrate tangent squared of theta. All right, so that was a lot of videos, a lot of stuff like that, and yeah, so hopefully that helped you guys, and I will see you guys in the next video with the next lesson.